Welcome back. Today we got a new patient here. It's a Taylor Hobson Surtronic 2, which is actually a surface roughness tester. Unfortunately the sensor head is missing, but it was extremely cheap. So I thought, why building the whole thing, including the traverse unit, buy something and just replace the sensor head with my idea I had a while ago, which is actually a turntable pickup. I've got roughness specimen in various sizes, and we got roughness specimen. I've got various different ones, but what they essentially do is these are all defined surface roughnesses, and you get the numbers here, and then we can calibrate this unit with this turntable pickup. It's a piezo one. It produces relatively high voltage, and these calibration pieces, they come in all sorts of different flavors here. Here we got very rough surface. They're all, this is I think that's turning or milling, and you can see this is almost like a rasp, like a file. Anyway, so we have a means of calibrating the whole thing. I did a brief check on it, and it all plugs into the back. Let me plug that in. It's relatively straightforward. It's the power supply for the motor and the sensor, and it's all on the back. I'll show that later. Just plug that in for now. And mains power. I looked inside before. It's safe to turn it on. So if you turn it on, it powers up, and then we can actually run. Don't know if that's visible, but it's moving back and forth. Not much. It's a little motor. It's a little AC motor inside, and I don't know how much it's visible, but it does that all the time until you switch it off. So this is all working. What doesn't work is the meter. That meter, it was hanging this way. It doesn't display anything, because what I tried was hooking up the scope on. There is an output on the rear, and if we look at the scope, turn the light off here. Sorry, the camera was running out of juice. If we look at the scope, and I'm actually touching the input just with a finger, so that's 50 Hz AC, we can see the amplifier is working, but what doesn't work is the meter. Put the light back on here, and closer here. What so whatever I do, it should bang the needle in the corner, but it doesn't. There's a range indication, so if I go to the lowest range and I just tap my finger on it, I can see it's already clipping on the scope, but it doesn't show anything. It's either the glass or the scale itself is probably binding on the needle. That's what it looks like. So we need to take that meter out and have a closer look, because the traverse unit works fine. So let's unplug that thing and have a look inside. A few more surprises inside. I took the screws out already, so if you take the top unit out, we'll see some badly deteriorated nickel cadmium batteries. They gotta go. They're not very nice, and light here. Yeah, they're in a really bad state, and they just standard D cells. Apparently, this thing operates with batteries and mains. Depends what you want. Anyway, they gotta go. The other side, it's actually nicely done, that case. So you had a look inside. Not much in it. Transformer, capacitor, a few transistors. They're actually AD162s, so that means they're germanium transistors. Okay. Alright. Oh, we need to check that blue electrolytic. That looks okay. The transformer is 18 volts, but it's a two-way rectifier, and I'm measuring 10 volts. That looks alright. So let's dig deeper into it. So we hooked up two wires to the back of the meter and just checking with a voltmeter here, and if I put my fingers on, we can read something. I think 0.4, 0.5 volts is actually the clipping already, because no matter what range I go, it doesn't go above 0.45 or something like that. So this is just hum, which is amplified from my fingers here. So the amplifier works, and so we need to check the meter. I think it's probably just the meter. The rest looks okay, it doesn't stink. The capacitor looks good. We need to check it if it's any good, or if there is any hum on it. I tried to figure out how old it is with some components, but yeah, I think it's probably late 60s, early 70s, just from the design and from the components used. Alright, let's get that meter out and have a look at it. So we got it out, and it's interesting, you can actually pull the scale out. The scale is just slid in here, and I think it was held with a plastic piece which slides in here, that holds the whole meter in. It's actually screwed on and held with these little brackets. The meter is extremely heavy. I think it's die cast. By the look at it. I think it's these two screws here and that bracket at the top. And then the front should come off. Yeah, it's getting loose. These are the holders. So I think that's actually real. That's real glass. It's got a thing here. Okay, and I think, just guessing, but I think this fancy bracket here needs to come out somehow. I think that's a spring. Quite a bit of load on it. Yeah, but it comes out. So how to get under it. There you go. one bezel, and that's the glass, real glass. So let's see what a meter does. The adjuster does nothing. It almost looks like it was just stuck. It was stuck at 0 because I don't know if it's visible because of that mirror, but now the adjuster works. It was somehow stuck on the, I think, the magnifying glass. I think this is just a piece of tape or so. The stoppers, make sure I'm in focus. These stoppers here, they're made of rubber, and the needle was basically stuck on the rubber for some reason. So if we put some voltage on, which we can do in the ohm range of the meter, we should be able to move that thing, and I would be very pleased if that's all of the repair. Wrong way around. There you go. So I'm just using the multimeter in ohm range, and it's got about 600 ohms. And apparently, if you use a multimeter, there is always voltage on the tips, so that's how you test these meters. And looks alright. So let's check for the full ranges. We're almost full range, so take another meter. And I don't know if that's visible, maybe not. So this is 0.136 at the moment for almost full, so I would say 0.14 volts for full range. That's what we want to see at the back of the meter. We've seen about 0.4 or so. Again, the meter is working, so all we do is go in the back of the meter and just hold our two ends on the pins. We're measuring 600 ohms, and that's about it. So again, I know it's very hard to see, but these little white things here, these are the stoppers for the needle. So if it bangs, it stops there. And all it happened was this was stuck on this one. Why? I don't know, but that was exactly the case, because the thing is perfectly fine. That's a bit of a relief, because these you won't get one. That's the rest of the glass here, which was broken off. I think this unit was dropped. That's what it looks like. We can rescue the glass, it's fine. I don't care about the little thing, we just need to give it a clean. It's got a little ding here, that's where the piece fell off, but yeah, whatever. Yeah, that's quite nice. So the unit is actually working. So we put it back together, give it a clean, and also yeah, you have to take the battery tray out, or lift it at least, to get the meter out, because it was a bit tight. So we're also going to check, there are screwdriver. There are two electrolytics, at least. There's one here and one here. I check at least the ESR. There is also, I don't know if it's visible, but there are some signs of battery fluid draining down, or was it water? I don't know. The battery tray itself looks sealed, so it can't come from there. It must be something else. God knows what it is. Maybe it's just some moisture. But yeah, the surface looks a bit strange. Same here. We can see some signs of fluid draining down here because there is some oxidation. Yeah, possibly a capacitor drained out. I don't know. We'll take the board out, have a closer look. Alright, we took the board out and we found some evidence of age. These Fraco 100 microfarads are made in 1970. So this thing was produced either late 70 or early 71, because I don't believe they used old stock parts when they made these things. On the meter it says 1071. That's where it starts with. So possibly 71. I would say around about 71 the thing was made. So pretty old. Still in good nick, but it's still that residue here. It doesn't look like being drained from the batteries, except they've been changed at some point, but it looks more like moisture or so. Or maybe you need to check all these capacitors. Maybe one of this. In these days they usually didn't explode this way. Anyway, we'll check this anyway. So I think what this circuit actually does is it's producing the AC for the motor, because you can switch different frequencies. What I've seen is if I change it to 9.5mm from 3.5mm, there's a switch here on the back, it doesn't change much, so I need to check what the frequency is, because these two transistors are probably the output stage for it. So it maybe be with short in voltage here. We need to check what's going on there. Yeah, that's a transformer, I think. So that's some sort of chopper, which makes AC for the motor. I think the voltage was quite low. It was 5 volt or 6 volts, which went to the motor. No, sorry, the motor was 14 volts or 15 volts. What I was measuring on the terminals when the motor wasn't running. And obviously with a variable frequency, because that's generated by this unit. And I think the switch is just switching around between different capacitors, I think. That resistor looks a bit weird. It looked burned, but it's actually just a 10 ohm resistor. Anyway, now we know how old it is. We'll sort the cleaning out, check the electrolytics, and then we'll make part 3, where we do some experiments with the stylus and see if it's actually measuring something. I guess I need to figure out a little bit with resistors to make that working okay. Perhaps I use a moving coil one or a moving magnet one rather than the piezo one, because I think that produces a lot of output voltage. I have no idea what the original sensor is, because I have no manual and there is nothing to find on the internet. Again, if someone has a manual, it would be much appreciated if I can have a copy, or if you can send it to me, I'll take a copy and send it back. I don't believe there is anything in electronic form from this age. Okay. It needs a good clean, and that's about it. Which is always the best repair if you don't really need to do anything. And yeah, the lights, there's a bunch of lights here. It's actually lights, it's not LEDs, and these are all switched via these multi-pin connectors here. Obviously the meter was soldered, so I unsoldered it. Anyway, that's it for this episode, I would say, because I need to take the battery tray out and clean that thoroughly, because that stuff is aggressive. That will take me a while. Just get rid of the batteries, give it a good wash, and then put it in a dishwasher, make sure everything is gone of this stuff here, because it's, yeah, whatever comes out of batteries is never good. The springs don't look very nice either. This spring is very much a lot of corrosion. We won't use batteries at the moment, so we're just running from mains. At some point I may use some rechargeable batteries, but since nowadays rechargeable batteries have a lot higher capacities, I will use some of these adapters where you can actually adapt a A cell to a D size. I have some of these, they're very cheap, they're about 50 pence or something like that, and you can buy them pretty much everywhere from China. And I've done that with other devices. It does well, because the D cells are pretty expensive as nickel cadmiums or lithium batteries, whereas the A size is much cheaper, and it's got about the same capacity. Serial number is 355-100. It's interesting. It says Rank Precision Industries, but this is a Taylor Hobson. Maybe they are owned by Rank now. Maybe that is an indicator when it was made. We'll find out eventually. Anyway, I just had it sitting on the bench for quite a while and wanted to see if it actually works or not. So yeah, we are okay so far. Have a look at part 1 of this series. It's called Hobson Surface Roughness Tester, where I did some experiments with the turntable stylus or turntable pickup unit, and so that will be the replacement for the original Taylor Hobson sensor, which I don't have, except I can find one in the meantime. So in the first part I said I'm gonna build a traverse unit, but why should I? Because I have one now. And this was, don't know, it was pretty cheap. Yeah, it needs a bit of work, but it's a nice unit. Anyway, thanks for watching. Thanks for subscribing. Until next time.